Hello, everybody, and welcome back. It continues to be Advent of Code. We are here on day 11. As the December progresses, the challenges they might get a little harder step by step. So, all the more I'm excited about the fact that you still decide to join us, that you decide to tune in and spend your afternoons, your evenings, or whatever time zone you may be in with us 12 hours after the puzzles unlock to discuss, maybe learn something new about Kotlin, all those kind of things. So, as usual, if you are here, please drop us a little line in the chat. Say hello. Make it known that you're here. And as usual, I am very curious to hear some thoughts about today's puzzle. Because without taking too much away from the discussion later on, when the inputs get shorter, that's when I get real nervous. Because for me, that always feels like there's going to be some big numbers involved somehow. Or some long steps of computations. Which puts me into a state of slight unease. But luckily, now that we are here, of course, we have the nice lo-fi Christmas music playing. Now that makes me a lot more chill again. Oh, look at that. We have a couple of familiar faces, as usual, in chat. Jelly Owl, hi. Glad to see that your messages are going through again. Dave Leeds is here as well. Very nice. If you haven't checked out our chat that we had a couple days ago, make sure you go back and watch that. Well, after today's stream. And of course, a bunch of other folks. Maya, Jonathan, Zelt, amazing, nice. Very good to have all of you back. Already have a couple of cool comments here. Part 2 was so satisfying. Just add memorization to my recursive DFS solution. Reduce runtime from years to milliseconds. Very interesting. Trying very hard to think now if I have a DFS somewhere in my solution. And I don't think so. So I'm now all the more curious about what it is that you constructed this morning. We're seeing something where some hints that maybe parts of the actual instructions may be slightly misleading. Who knows? That the order is important, but maybe it's irrelevant. Interesting. And some disappointment that there was no test data for part 2. Interesting. Yeah, I'll be honest with you, when I saw this, just when I looked at the input, I was like, I'm just going to briefly refresh myself on the Chinese remainder theorem, just in case, before I even finished reading the entire description. Because you never know. And it is one of those things that does seem to come up, and that I continuously, immediately forget after the challenge is done. With memorization and DFS, I'm still waiting for an answer for part 2. Interesting. Johnny used memorize deep recursive function. Took way too long to get it working. But Johnny, did you actually manage to get it to work? It's very funny because I just had a discussion earlier today with a colleague about how memorization might work in Kotlin as opposed to other languages, and the memorization page from Arrow did actually come up. There's a basic version of simple memorization which just has this like utility function called well, that link should probably be fixed by someone, just called .memorize. But they also have this memorize the deep recursive function, which has like a much deeper or has a different type of calling convention. I swear when I clicked this morning, this was a different link. No, it's the same link. It's this one here. So you can just drop that in here. We'll see. Yeah, I got it working in the end by passing my own cache class in the constructor. Interesting. I love seeing all the different kind of approaches that people take. Couldn't solve part 2. The time for a stone calculation grows exponentially. I've only reached 48 blinks. Okay, but I think with a little trick here or there, we might be able to still work out an approach to part 2 as well. I just let it run and went, did my day job, only to see now that it didn't finish. Yeah. When the out of memory errors happen, that's always that's a bit of a bummer. But here's the fun part. Historically, at least for me, this has been a valid strategy before. I don't remember which puzzle it was, but a couple of years ago, I must have done one advent of code where my solution ran like 40 minutes and it arrived at the correct solution without running out of memory or without running out of stack frames. So that was quite satisfying. Really felt like I was, sticking it to, I don't know, the people who are smarter than me who come up with a better algorithm. Who knows? 2021 day 6 or 14. That may well be the case. We have enough of a puzzle today to talk about, but I just want to briefly shout out, by the way, my colleague Maton, who you may have seen during one of our streams as well, when we were in person. He provided me with a user script called AO Kotlin, which now finally does the thing that we were joking about when Roman Belov was on stream, which is it's no longer AO C++, it's AO Kotlin. So yeah, that's just a little client-side patch that changes this. And it also saves me the time to find the right sponsor in the sidebar, so that's nice. Okay, well, I think everybody who wants to join has had plenty of time to join. So I think it's time we get to puzzling. And like usual, I'm not going to be doing that alone. I'm very excited to bring my guest on today, which is Renette. Hey, Renette. Good to have you.
Hey, Sebastian. Glad to be here.
So, since I was just talking with the chat about some of the previous Advent of Code events, you've been doing Advent of Code for quite a while, right?
Yeah, I've been doing it for a few years. I think the first time it started out because I wanted to learn Kotlin, and then there was a company leaderboard, and things got competitive, and I'm still here.
That's amazing. That's I mean, hey, it's so cool when you compete with some folks. If I take a look at our internal leaderboard, I can still see that from a historical perspective, Roman is still in this. So I'm not really battling it out with Roman Yelizarov. Let's be very honest here. I think he has a good half-hour lead time on me on everything. But it does help with keeping the motivation. So in the first year you did Advent of Code, you immediately started with Kotlin?
Yeah, I wanted to learn Kotlin because I've mostly been deving in Java up to that point. So that year I was still mostly learning Kotlin. I think that must have been back in 2017 or 2018. Mm-hmm. And then the years after that, I just stuck with Kotlin.
Very nice. That's really exciting to hear, of course. And did you in that first year? Because I'll be very honest with you. First of all, for me, I mean the problems get pretty tough after the second half or after we've entered the second half. But also real life just kind of tends to go in the get in the way. So I'm just curious, you for the first year you immediately went to day 25?
No.
Okay.
I don't know how far I got. Probably 20-ish with a few skipped, and then I went back later and finished it up.
Very nice. Yeah. I'll be honest with you. So for me, this is always it's very tough because I feel like I want to Like I'll not look up a solution and then submit it because I'm like, this is like advent of code, it's like holy. But then the other problem I have is that outside of the advent of code, I don't have enough time to invest into the puzzles. So like for a lot of the for a lot of the previous events for me, there's still a whole bunch of stars that, you know, I'd like to imagine I go back to them eventually, but so far I haven't managed.
It's easier if you're like missing 1 or 2 stars in a year because it's like almost there. But when you haven't done a year at all, it's very, very hard.
Yeah, that tantalizing effect of like they also do this very nice thing. Let me just see if I can find one where this is like super obvious. In some of these, like the animation or like the coloring stops with the if you have like a hole in the middle. I'm pretty sure. I'm not sure which one it was. So it's really like you really want to get that like that little sparkle or that little color in to get the entire drawing. That always kind of motivated me. But with someone who has like a whole bunch of experience, how do you feel about this year's Advent of Code so far in terms of like overall difficulty, in terms of maybe how it like ramped up? Anything unexpected happened so far?
So I definitely think it started out much harder last year. This year it started fairly easily compared to last year. Up to now, I've been pleasantly surprised because I haven't needed like any really smart solutions for any of the part 2s before today. Right? You could almost all of them you could just brute force and it would finish within reasonable time.
That's true, but I've said this to I think maybe I also said this on an earlier stream already. I feel that this year's problems are very good in the sense that you get very far with a brute force solution, but they are designed in a way that immediately invite curiosity. Like, at least for me, with a lot of these problems, I'm like, well, I've done it. Like, that feels good. That's a load off my back because I'm like, I have something I can present. but then I'm like, but there has to be a nicer way of doing this. Like, if I massage this code for a while, or if I change my data structure, like, there's probably a way of eliminating some edge cases, or just to make this whole thing a whole lot faster. Yeah. All of these things, which I do like that. And I did not have that feeling in some of the previous years.
Yeah. I think previous years it was, at least last year, I can't remember that far back, it was definitely more of a, like, don't solve it at all, then you can do it. You solve it, but you can do it nicer.
Yeah. Zelt here says, I told my colleagues, Advent of Code in Kotlin is almost like cheating. So many functions feel like they're made for the problems. I'm glad to hear it, and maybe we'll see a couple of those today as well. Use Java before Kotlin whenever. I used Java before, but Kotlin whenever possible. Sadly, I'm working on an Angular frontend at the moment, so Advent of Kotlin is the nice part of the year. Okay, all right. Just had my first day on my first Kotlin job. Congratulations, Rob. That's so exciting. That's awesome. Really, really lovely to hear. And after using Kotlin, I won't use Java anymore.
When we can choose.
Yeah. No, that's really great. Okay, so I'm really excited to hear your thoughts on today's puzzle and see how we get to an actual solution here. So I'm gonna just pop on my my reading hat here that has been notorious for getting us all the stars. We'll take a little look here at the problem statement and see where we get from there. For day 11, it is Plutonian Pebbles. The ancient civilization on Pluto was known for its ability to manipulate space-time. And while the historians explore their infinite corridors, you've noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Sometimes the number engraved on a stone changes. Other times, a stone might split in two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in this list. If the stone is engraved with the number 0, it is replaced by a stone engraved with the number 1. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the new right stone. The new numbers don't keep extra leading zeros. 1000 would become the stones 10 and 0. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. No matter how the stones change, their order is preserved, and they stay on their perfectly straight line. How will the stones evolve if you keep blinking at them? You take note of the number engraved on each stone in the line, your puzzle input. If you have an arrangement of 5 stones engraved with the numbers 0, 1, 10, 99, 999, and you blink once, the stones transform as follows. The first stone 0 becomes a stone marked 1. The second stone 1 is multiplied by 2024 to become 2024. The third stone 10 is split into a stone marked 1 followed by a stone marked 0. The fourth stone 99 is split into 2 stones marked 9. The fifth stone 999 is replaced by a stone marked, that's a lot of digits, 2,021,976. So after blinking once, your 5 stones would become an arrangement of 7 stones engraved with the numbers 1, 2024, 1099, and 2,021,976. Here's a longer example. We're given an initial arrangement. We apply the rules repeatedly and get a list that seems to grow rather quickly. I think if we zoom out a little bit and we kind of squint, we can kind of see that there is a growth that happens to become faster as the blinks continue. In this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, you would have 55,312 stones. Consider the arrangement of stones in front of you. How many stones will you have after blinking 25 times? First of all, let me just say that for this one, reading this out, I sometimes feel my my German roots a little bit every time I look at a number like this. In German, unfortunately, we have made the big error on the linguistic scale that we say the ones digit before the tens digit. So I always stumble. I always want to say like 67, which is not what that number is. Anyway, okay, Renette, what went through your head when you read this morning?
So the first thought was kind of like, I hope it only becomes difficult in part 2, because I noticed it grows quickly, but I couldn't think of a smart solution that quickly. So I started out just like making a list and simulating the thing, and just hoping it wouldn't grow too quickly for the 25 blinks.
Yeah, I mean that's typically my first approach as well. You never know if they are actually trying to throw you for a loop, or if the straightforward solution does actually work. One thing that confused me a little bit, and I think this is also something that someone shouted out in the chat a little earlier. If I can just find it, hold on. Someone mentioned that the text mentions that no matter how the stones change, their order is preserved, which was very curious because I looked at the entire problem statement. I was like, this does not that invariant does not seem to become important, at least in part 1. So that was just something I kept in the back of my head there. But I'm just gonna throw it over to your screen here for a second, and you can walk us through how the basic simulation of doing this would work. So you're up on screen, and we can take a look.
Great. So what I did, obviously, just start out by splitting the text and mapping it to longs, once again, because I wasn't sure how big the numbers would grow. And then just for the number of blinks we had, which is 25, just using the repeat function to run the simulation multiple times. Every time taking the list, using flat map and applying the rules. If the stone is 0, it just becomes 1. If it's got an even number of digits, so we convert it to a string and check the length, then we get 2 new ones, the first half and the second half. And then the last rule, we just multiply it by 2024. And then at the end of the number of repeats, we just check the size of the list.
I mean, that's that's pretty straightforward. I do like the use of flat map here, because of course you have some scenarios, like the case of the 0 and your overall and the else case with times 2024, where you do only return a single value, but you also have a case where you have more than one value. Okay, here's a quick question for you. Did you get the offsets in the substring right the first time you wrote them?
Yes.
Okay.
Because I was thinking if the string has 2 characters, then it's 1 and 1, right?
Yep.
So because it's always even, it's easy, right? If you have a mix of even and uneven, then I usually mess it up, because then you have to know if you have a +1 or a -1. And the flat map kind of annoyed me a little bit, because I was but sometimes it's just a 1 list, and that seems a little bit wasteful, just making this list for 1 item.
Yeah, no, I can see that. This is actually it's one of the reasons. Well, 2 of these reasons are kind of why my code is a little is structured slightly different than this. I can actually just throw this up, because we took the same approach here, but the way that I ended up writing it was slightly different. So hold on, I'm just gonna switch this over here. Here we go. So my part 1 was just okay, well, first we parse the input. I like that you just essentially read the entire text and split it. I had a little bit of I had some trust issues with my input, because sometimes there might be I might paste it in and there might be a new line or something like that, and then maybe that messes things up. I don't know. So even though I was perfectly aware that the input was just 1 line, I was we'll read all the lines, we'll grab the first one, and then we'll split it out and work with some longs. And yeah, then I decided, okay, we have a starting kind of combination, and then again the beautiful repeat function was just okay, we'll blink 25 times, and after each blink we just update our variable here with the new configuration. So this is essentially just the update loop, and then we can also return things. By structuring it this way, essentially, I also still return a list, but I build this list in using these collection builder functions. I've really found myself, I don't know what it is with this year's Advent of Code. Maybe I just wasn't so privy on them, or maybe Michael Zarachinsky, on the second day, coming in and saying hey, you can do a whole lot of imperative things as long as you keep them small. There's no one telling you have to do functional. Where I'm hey, I can just whip something up quickly. Or it's just okay, I can just loop over my stones. And I can just add elements to my list here. So I can add either 1 element, or in the case of having 2 elements, I can just call add twice. And here you can see that I did not trust myself in the morning like you did. So instead of figuring out the ... less than divided by 2 and then It's like, well, it shouldn't be +1. It should just be divided by 2. I was like, I'm just gonna do just take take half of them and then take the last half, which is just the other half. It's just a tiny little shortcut that I took here to feel slightly more safe at this time. But yeah, so I forego the flat map or the extra allocation of a couple of lists, but I have a feeling that later on I'm probably gonna be allocating a whole lot more than you. Not really, not sure, but something like that. Stone.chunked it.length divided by 2. Oh, I like that one as well. That's fun. So that would be like we have our stone to string. There we go. Am I? Isn't this exactly? It's this symbol. Why? Well, x equals stone dot. Oh, there we go. Stone to string, and then chunked with size length divided by 2, which gives us 2 chunks, so we can immediately say like first, second. We can like destructure them and then add them. That's a fun way of doing it as well. Honestly, that I can't tell if that's more expressive or less expressive. Thoughts, Renette?
Not sure. Chunked on a string is a weird one for me. I'm used to doing like chunked and take on lists.
Mm-hmm.
Doing it on a string is a bit of a weird one for me. But then again, we don't really write a ton of code to come back and read it.
That's very true. That's very true. Well, to be fair, even my take and take last, I suppose, those are typically like the collection operations. I just happen to.
Yeah, when you do them, that's kind of cool. I'm used to doing take and drop on lists, not on strings, but it makes sense. It's pretty cool.
I'll say this. It is very nice if you know that you're working in ASCII. This is like one of the great parts that I always love talking about. It's one of the things that is fundamentally different between Kotlin and, for example, Swift, right? Swift, when you iterate over a string, you operate over graphemes, which are like the Unicode primitives. So if you have an emoji, like a family emoji that happens to be made up of like a father, mother, and like 2 kid emojis, those are like all joined together. So if I'm unlucky and that happens to be exactly at the split, I truncate that string, I might end up with just the parents or just the kids and accidentally truncate out like half of that visual character. So there's just treating strings as a collection of characters is a blessing and a curse. Here it's a blessing, but in the real world,
I suppose that would apply to substring and all the other string things as well.
That's very true. Yeah, because even those kind of treat them just as a collection of characters. But yeah, so for graphemes, when that happens to be the case, I'm very glad that Eric Wastel has so far not decided to throw emojis into the mix. I'm sure that we would still be off pretty well compared to the people who solve it on like a Amiga 2600 or whatever, or decide to solve them in Excel, would have probably a harder time. But yeah, I mean, this is a pretty straightforward way of doing it, either direction. The question, does flat map negatively affect the performance? I'd say, given the size of numbers and size of collections we're working here, not really. If you're like optimizing like every last instruction, then the answer is benchmark it and find out. We have learned this on day 1, but I mean, people
well, those extra list allocations do feel wasteful. They are pretty good optimized. There's like special implementations of lists for like the singleton items, so it's not that bad.
That's also very true. I think if we just write list of 1 and we like click into this, well, that was. Oh, what a bummer. Okay, I guess my navigation doesn't show me. It does not show me implementations. That's a bummer. If you do look into the implementations, which you might be able to do at home depending on your version of the tooling, you will find indeed that empty list and like single item list are behave differently than the full collection. So yeah, you're absolutely right. While it might feel wasteful, the real impact here is absolutely negligible. Plus, it might just make for some nicer code. Okay, cool. That was quick. I'm excited that we get to move on to part 2. This is almost not even worth putting the hat on for, but so far it's been trusty. And now we also see what we mean by people complaining that there was not any additional test input here. Part 2 is the historians sure are taking a long time. To be fair, the infinite corridors are very large. How many stones would you have after blinking a total of 75 times? Renette, what do you think here?
So my first thought was, well, I kind of expected this. This is like every Advent of Code. There's one of these where it's like, do it 5 times. Now do it 5,000 times, right? And then I saw 75, and I was like, how bad can 75 be, right?
Yeah.
So
how bad can 75 be? I mean, surely this is going to terminate like super quickly. I mean, while I already have it here. Yeah, look at this. We're already at 35. That's like almost halfway. And ooh, that 40 is already much tougher. And yeah, okay. Maybe we need to do something. I think like Maya mentioned beforehand, this might not be the way. What I also find very interesting is all of a sudden, even though this is a single-threaded process, I'm getting like CPU spikes across the board. I'm getting like 600% CPU usage. I assume that's the garbage collector frantically trying to clean up after ourselves for like short-lived objects or just allocating more things. Who knows? So yeah, this one does not seem quite as straightforward. Let's look into your thought process here. I'm gonna throw up your screen. Let's see.
Cool. So the first thing that came up is that whole is the order important question, right? I realized after thinking about it for a little bit, that order is preserved actually doesn't matter, right? If you have a 0, it's gonna behave the same way, regardless of where in the list it is or when in the list it is.
Yeah.
Right. So then I went with a solution that just uses recursion and memorization, right? So I've got a cache and mine's nested maps, but the important part of the cache is it needs to have 2 things. It needs to have the stone and which iteration we're at, right? So we're gonna start at 75 and then we're just gonna count down, use this recursion function. And inside the recursive function, if we're reaching the end, right, then there's 1 stone, it doesn't multiply. Then for the actual cache, I use get or put. Get or put is like one of the most convenient functions for Advent of Code when you've got any kind of caching or memorization going, right? And then we apply the other rules. If the stone is 0, we just change it to a 1 and count it, and -1, so 75 becomes 74. If it's even number of digits, we do the substring thingy again, and now here we need to count both. So we count the number of stones starting from the first one and starting from the second one and add them together. And then the final rule is just multiply by 2024. Actually, at first, I missed this stone equals 0 rule when I was just copying code over. And I was like, but why is my solution not even working on like the most basic input? So I had to go like, okay, at which iteration does it fail? And then I figured out, oh no, I just missed one of the rules. So yeah, and then here it's like with 75, it becomes very important to use long. And interestingly enough, the first time, what I usually do is while I'm working on part 2, I'll just like have started running. Maybe it finishes before I finish the code, and I get lucky, right?
Yeah.
And then actually ran out of memory because I think the way my Gradle project is set up, it does not give a lot of memory to this process. So it actually ran out of memory pretty quickly because what happens is a lot of the internal stuff is array lists, and then it needs to like copy them, and then
So I'm curious here because I mean we'll take a look at my solution in a second, but my first thought when I saw this was not recursion, and my solution does not use recursion. So I'm very curious. Like, was it like immediately when you said like, okay, large numbers need to do some things, you were like, this is recursion plus memorization? I've done that before in a different context, or how did you get to picking this solution and running through it?
It was kind of instinct. What happened was I was like, like 0 is always going to behave the same way, so I can cache it, right? And then immediately when I went caching, I was like, oh, that always goes with recursion. I mean, that's not entirely true. You can have memorization without recursion. It's just they kind of go together in my mind. So when I thought like, oh wait, I can cache it, it was like, and then just kind of belongs with recursion in my mind. So
okay.
And the other thing is just kind of this like, oh, just do the same thing on the next iteration. Yeah.
Interesting. Yeah. That's. I mean, I think it's a super cool instinct to have, and being able to pick that out as a solution here. I also there's a couple of very valid points here. why is there no cached like in Rust in Kotlin? The answer for this is something that we very briefly discussed beforehand. We have this through the arrow library. We have this funky memoized deep recursive function. I'm just gonna throw that one up here again for a second, which essentially allows you to write something similar. But I will be the first to admit that the syntax is not quite as nice as just being able to write at memoized. Because we are on the JVM, most of the time at least, you can, of course, use like Guava caches, or I believe that the Spring framework, it just has like an at memoize annotation. If you want to play with that, I would very much encourage you to do that. And there's also just one more other question while we're already talking about the JVM. Would it execute faster if we compile the code using Kotlin native? Is it straightforward to do for advent of code style programs? That answer for that one is twofold. Is it straightforward to do for advent style programs? I'd say so, yes. If you grab yourself... I'm just trying to think if we have like a good starter for this. I think probably the wizard has... Let me just see here if we have a Kotlin native example. We have Kotlin. Oh, that's just JVM. I think if you just Google for a Kotlin native template, you should be able to find one, and then it's as easy as like running it from the desktop. The real question is it going to be faster? And the answer is probably not. It'll start faster, because it doesn't have the JVM like warm-up time and all of that, but the JVM is very fast. There's a good reason why we use that for like server-side development and all these kind of things. So the answer is really like it depends. But yeah, I'm actually curious now that I'm looking here at the arrow library. When you do advent of code, do you always do it in like plain Kotlin, like no extra libraries, no extra functions, or do you have like your
try to? I've got a bunch of helper functions that I copy over every year, stuff like the normal graph search and just coordinates and stuff.
Mm-hmm.
And I try to just stick with normal Kotlin and sometimes just Java classes when like a priority queue if I need to do any kind of graph search, right? I don't think Kotlin has one of those.
Yeah.
And then last year there was one problem where we had to do like asteroid collision stuff, and basically everyone said just use this other library, which It's such a complex problem, and really no one wants to implement themselves. Everyone says, just use this library to solve it.
That's the best way of solving a puzzle, is delegating it to to an existing library. Yeah, but yeah, for me, I always try to do these things from scratch, which it costs me a whole lot of time. The one thing that you're absolutely right about, though, today when I first implemented things, I was very worried about the big numbers becoming like big, especially since it had this whole concatenation story going on again. So I was like, okay, I'm just gonna start with big integer, and we'll work our way backwards from there. In the end, it didn't really matter. Longs were all that was really needed here. But I would also just very briefly like to note, and I'm not sure if this is intentional from Eric Wastel, but I felt like this is now the second time in this advent of code that we've had like a number being split in the middle. Which immediately my mind went like, oh, we've done this. We know that we can use like a logarithm +1 to get the number of digits and then multiply things. And then I also remembered that wasn't actually faster than just calling toString and taking any elements. So
I
was
actually
like,
wondered
yeah.
about that, because I was like, well,
Yeah.
I know there is a math way to do this, but it was 7 a.m. and I don't do math at 7 a.m. very good.
Understandably. I mean, it was 6 a.m. here, and doubly so. I was like, if the thing standing between me and the second star is gonna be like a toString, I probably need to find a different algorithm. But yeah, so let's take a quick peek here, because the first thing that I actually did after I finished part 1 was the following. I took a look at the result of the first part. Well, okay, this is just the right now that's just the entire value, so let me just jump in here. We'll change this back to 25, and I was like, after these like lines, what I can just do is I'll grab my modified line, and let's just do like a quick grouping by, and we'll just take a look at how many numbers of what type we have. And this is kind of what I looked at, and I was like, there's a lot of like clustering that seems to happen here. Like, yeah, there's a bunch of like large numbers, but oftentimes it seems like there's maybe like some of these numbers have like 1,000 or like 4,000 or like more elements. I was like, I can probably just get away by, rather than instantiating each individual element, I'll just keep track of however many I already have. And that's the way that I approached part 2. So for part 2, I built myself a structure that is very pretentiously called a non-materialized list, which just has a single operation called add, which allows you to add elements of type long together with their count. So you can say, okay, I have 1,000 longs, like I have 1,000 longs that are like 1 to 3L. And this is just backed by a map. It's just an interface so that my 6 a.m. version of myself can keep track of what the heck is going on. And then, so once I had this approach in place, I was like, okay, so first of all, we can just take whatever we start with, and we can turn it into a structure that works with this. So I can just I'll count everything and I'll group it, and I'll just put all of those into my list of stones. And now I just have this different type of collection that I can run the same algorithm as before on. So once again, we just happen to now have a list that is not materialized with all the values, and we do the same loop. We update it by blinking it in groups 75 times. And this, once again, I tried to make the code as similar as possible here. So I even built myself a little helper function called build non-materialized list, which all that does is create the list, then apply whatever I have in the lambda, and return it. It's just a typical pattern. If I didn't want to be quite as pretentious, I could also write something like a non-materialized list.apply and then just write everything in that block. It would behave exactly the same. But yeah, the actual code in here is pretty much the same. Now we're just grabbing ourselves not just the individual like stone that we're looking at. So I guess I should probably rename this as like a stone. But in addition, also how many we had of those. And now we just apply the rules in entire batches of stones. We say, okay, if our stone group happens to be a 0, then we will have to add however many stones that with 0 we have to add the 1 stones with that. And the rest of it is exactly the same. Like the code stays the same. We just add a lot more stones into our map. And then the final part here is just that our logic for calculating how many stones we have in total just rather than just counting how many values we have, we actually need to sum up the number of elements in each like non-materialized group. So here there's no recursion, there's no caching. It's the exact same like fundamental algorithm as we had in the first part. And when we run this, it also terminates in like 40 milliseconds, which is more than enough for me in the mornings. That's not enough for me to brew a tea. Yeah. So I'm very curious because this was immediately where my mind went. I was like, if I could only get away from like instantiating all of these elements, I was worried it was going to be recursion. But I just kind of went down this road. Thoughts?
I love it that there's like these two complete separate solutions that you can do to solve the problem. I didn't even think of this until I read somewhere, probably in the Slack, that people were like just doing the count. I was like, oh, that's interesting. I never even thought of that. I was just kind of thinking about how do I handle each individual stone, not yeah.
And I have to say, like in return, I was actually so surprised to see your solution like work so well as well, because in my mind I was like, even if I were to go through this with recursion and I can make the individual operations really fast, like in my mind, like looking at like the tree, I'm like, I'm not convinced that this tree of operations that I have to do at the end, even if I can cache subtrees, isn't gonna grow like very, very large. I think maybe my intuition was just slightly misaligned there.
No, I think it works for the same reason that yours works, and that's that the numbers keep repeating, right?
Yeah, which again, sometimes I am really in awe of how how well crafted the inputs are for these things. It seems like an even harder puzzle coming up with the valid inputs here. Zelt says, I must admit, I also spent a lot of time trying to figure out how to make use of the loops created by 0 to 1 to 24 to 20 to 0. Interesting. Yeah, there's so many ways of thinking about this. I was very happy that no modulo calculations were required here, because those are always the ones where it starts getting a little fuzzy in my brain.
Every time you involve both modulo and negative numbers, I'm like, how does that work again? And it's like, and it doesn't even always work the same, right?
Yep.
Not like in all languages. It's like, how does this work again? And
I mean, even in Kotlin, right? Like, if you have like we have the rem function, .rem, I think. Hold on, -5.rem, which happens to behave differently than like -5 divide by 2. I'm pretty sure those two are the two different ones.
yes.
Yeah, but we have remainder. Oh, not divide, percent. So we have remainder and we have modulo. Dot mod. Yeah, dot mod. So we have remainder and modulo. Yeah. And those fundamentally behave differently. I think in the description, at least on one of them, I think that the long form documentation says this more, spells this out more with a couple of examples as well, that that the behavior with negative numbers just changes.
That says it there, right? It says the result has the same sign as the dividend, and the other one's doc is different.
Yeah. So this one has the same sign as the dividend, and this one is either 0 or has the same sign as the divisor. Okay, so now we really got to go back to like our middle school knowledge and remember which one's the which one's which.
That's not even English first language. So what's the chances that a middle school knowledge is in English?
That also, yeah, that adds to it. At least in German, I think it's Dividend und Divisor, so at least the letters are the same. I feel like I should be able to know this or figure it out, but you know, I could probably just ask Wikipedia as well. Yeah, but people have noted here that apparently this was very close to Lanternfish, which happened in 2021, day 6. I'm very curious. I don't know if I solved that one. 2021, day 6.
I remember that day it made a lot of people give up.
Oh, I did do it.
I was trying to get some of my colleagues into Advent of Code, and they were like, no more Lanternfish.
Which is, I mean, I'll be honest with you. This is now a day 11 puzzle. Throwing this out on a day 6 is tough. I think that's a real toughie. But yeah, so far I think the learning curve for this year, or the difficulty curve, has been pretty good, pretty consistent, honestly. Nothing that made me want to quit on day 2 anyway. But yeah, also the other point, of course, is like looking at the final number. It is a big number, so you will not get away with ints here. And I did submit my solution first with an integer, and then I think I once again did my patented strategy of moving my print statement into the loop for part 2, and just taking a look at the values, watching them fluctuate between pluses and minuses, and being like, okay, I know where the problem is. So, I mean, I think that covers most of the things that are part of this puzzle. I love that we had both a recursive solution and just an iterative map cache type solution. I'm curious, since you do have a whole bunch of experience with previous Advent of Codes, of course, what have we not seen so far? What are your predictions for the next couple of days?
So 2 things. We haven't seen a lot of like graph traversal stuff yet. The one we had was very basic. It was just like direct neighbors, no costing, no anything. So I expect to see one of those. And usually there's also simulate a little microcontroller or little computer kind of thing. There's usually 1 or 2 of those as well.
This is
There was one year where it was like almost half the problems, which was a lot of fun if you got it right, but a lot less fun if you missed one of the days.
Yeah, I think the int code year like lives.
Yes, that's the one.
infamously.
That's the one. It was a lot of fun if you did int code properly the first time, but if you missed a day, it became less fun.
Yup. But I'm still. This is something that I was talking to my buddy this morning. I think we both had our fingers crossed for like a little interpreter, a little something like having some sort of architecture, changing some instructions around, simulating some programs. So I suppose we'll see. We still have a couple of days left in Advent of Code. We're not even halfway. But it's probably important to note that tomorrow is going to be our last Advent of Code stream here on the channel. So if you don't want to miss that, make sure you head on over to our stream page, which I'm just going to link you here again for a second, and hit that little notify me button. And while you're already on the page, I of course also encourage you to make sure that you are subscribed so that you don't miss any of the upcoming videos that are coming out, because they're right now in post-production, I can already tell you, and they're gonna be great fun. Plus, you don't want to miss out on when the next time the design team treats me to like one of those thumbnails where I clearly intended for them to put a Christmas ornament in my hand, and they just didn't. so and but at this point I've just decided to embrace it. This is just the picture for today's stream. Maybe it'll make people click more in the recording, wondering what the heck is going on there. They left you hanging. That's a very good pun. I enjoyed that a lot. No ornament, Seb. Yeah, wonderful. So Renette, thank you so much for coming on today. I really do appreciate it.
Yeah, thank you for having me. I enjoy this.
Are you planning on going the full 25 days this year?
Yeah, I'll probably do it.
I start every year with that intention, but so far I've never made it because real life does happen at some point, and I'll also be honest with you, it's the time to be kind to myself sometimes and afford myself a break. And maybe spend that 6 a.m. wake up time that I did cultivate since Advent of Code has started for something else. I don't know. Maybe I'll go for a morning run in the cold, or something like that. It's the time for reinvention. Like the good New Year's resolutions, we can start those early. All those kind of things. Okay, great. Well, once again, thank you so much for joining today. And of course, thank you to everybody who decided to join the stream. We're very excited that we got to put these on for the first 12 days. And we're, of course, also very excited to be sponsors of the event this year, just like previous years. It's very nice to be a real part of this campaign that allows people to engage with problems and, most importantly, engage with Kotlin and, finally get an opportunity to write their own list builder functions or something like that if you so desire. If you want to interact with Advent of Code and Kotlin a little bit more, you've seen this blog post before. I'm still gonna post it anyway. Because we have an entire campaign running. Next to the streams, we have the leaderboards. You don't need to compete for top spots. As long as you join a leaderboard, you have the chance of winning some exclusive Advent of Code swag. And of course, we have the templates. If you want to try a new build system, besides Gradle, where we have a template, you can also try Amper, for example, which might be quite nice. And of course, we have our AOC 2024 in Kotlin topic. As long as we can reach you and you have your repository tagged with the AOC 2024 in Kotlin GitHub topic, and you solved a couple of problems at least, you have a chance of winning again. So we can check in here again and we can see if we've gotten any extra ones. 869. That's a small growth since last time, but once again, the big call out here, if you haven't done it yet, now is the perfect time. Again, it's a lovely way, by the way, also to discover some other folks' solutions, like AOC and Kotlin notebooks, for example, or whatever else you might find, including this behind-the-scenes repository where you can find a whole bunch of the solutions that we've seen on stream, and you can explore those as well. So yeah, with that, we can take a look. There are 11 hours left until the next puzzle, so I look forward to seeing you at the usual hour tomorrow, and I wish all of you the best of luck with solving tomorrow's puzzle. My prediction or my hope is going to be that it is an interpreter of some sort, but I suppose we'll see. I have the Mazes for Programmers book still sitting on my nightstand for just in case, because you never know. All right. Take care, everybody, and hopefully see you tomorrow. Bye-bye.